Hi guys, so today we're moving on to chapter 5, qualitative variables as predictors. Qualitative variables are also called categorical variables, and we're going to see how to incorporate those variables into our regression model. So first, our data set is called ski cells, and it is in our textbook. First, we can go to our the R Markdown file, and make sure that you already set your working directory and put your dataset in the working directory. And we can load the tidyverse and import our dataset. So I already done that. First, we can see the names of the variables. First is the ID, is the case IDs. The second is the ski cells in millions. The third is the personal disposable income, which is PDI. And the last one is the quarter. So it's a quarter in a year. So in R, if you have a qualitative variable, it is better to change that into a factor. So a factor, how you can change a factor is to just use as dot factor, and like this way. So you can change that a quarter in the data set into a factor. So to see the levels in a factor, you can just directly call this variable, or you can just use the levels function. So let's see. So as you can see here, we have 4 levels for the quarter: Q1, Q2, Q3, Q4. You can also see it here. Okay, so let's get back to the our regression model. So first, we want to see if there's a relationship between the PDI and the cells. So we want to generate a scatter plot with a fit regression line here. So as you can see here, we have a strong linear relationship between PDI and cells. However, you can see the dots, those points are separated by this line, like into 2 parts. So it seems like we have like 2 grouped clusters here, two clusters here. Furthermore, if we group the dots by quarters, you can see here the first quarter and the fourth quarter are grouped together, and the second quarter and the third quarter are grouped together. You can run this code here. So this one is to generate the scatter plot you've seen, and these 2 lines generates like two graphs. The first one is just the one you see in the slides, and the second one is the same scatter plot plus the regression lines fitted into the graph by group, by the quarter. Okay. Next, since we sort of have like a linear relationship between the the PDI and the cells, we can specify our model. So we only include the PDI into our model. So the X here is the PDI, and Y is the ski cells. So this is our result. As you can see here, the PDI significantly predicted the ski cells, and this is the parameter estimates of the PDI. This is the estimated correlation coefficient. This is the t-test for the coefficient. And here we have the significant R square, which is like 80%. So PDI explain like 80% of the variance in cells. Next, so it's our overall model fit. F-test showed like we have a significant model. and this is the p-value for the f-test. Okay, next we want to see the residuals, how the residuals is going to be by our model. So in our R code, we generated the predicted y value, and this is the standardized predicted y values, and this is the standardized residuals. So we can generate those three. Oh, actually, we're going to first generate the linear model object, and the result is here. And we're going to generate those three values. Actually, we're just going to use the standardized predicted value and the standardized residuals. So first, we're going to see the normality of the residuals. We have two ways. First is to see the QQ plot of the standardized residuals. As you can see here, we have a weird shape. So the dots are not in line with the diagonal here, and this shows a violation of the normality. It can be clearly displayed by the histogram here. So this is imposed a normal distribution, and we can see our distribution here looks a little bit like bimodal. We have two peaks here. So probably, as we suspected, maybe Q1 and Q4 are grouped together, and Q2 and Q3 are grouped together to explain this peak in residuals. Also, we can see the standardized predicted value against the standardized residuals. As you can see here, it's the same situation. We have some of the dots, some of the residuals like clustered in like this one here, and some of the residuals are clustered around the -1. Okay. So two sets of residuals are evident, and the residuals plots suggest the association between the PDI and cells is different between two groups, Q1 and Q4 versus Q2 and Q3. So therefore, we need to include quarter as our predictor as well. However, please notice that we want to incorporate the quarter. However, we have 4 levels of the quarter. An easier way is to just group the quarter into only 2 groups. So we have like 2 groups like Q1 and Q4 and Q2 and Q3 together. This will be introduced later in our lab, like actually the end of our lab. And basically, we're just going to create a new variable to indicate, like a hot, like cold season, which is Q1, Q4, and a hot season, which is like Q2 and Q3. So this is something later. If we directly or directly put the quarter into our regression model, it will be dummy coding. And if we do something to the coding scheme, it will be effect coding. So those two may not be so accurate in this case, but I am going to introduce these 2 popular or very common coding schemes anyway, because you have to learn about it. So, but it may not be making much sense in this case. Okay, so let's get started. So we have, as we said, we have 2 coding schemes to incorporate a categorical variable into the regression model. The first one is just called dummy coding. The second one is effect coding, and in this case, we're going to use the unweighted effect coding suggesting that we have a same sample size in the in each group or in each level. So in this case, is in each quarter. And there are a lot of other coding schemes like contrast coding and other coding. We are going to talk about that. I think we're not going to talk about that in this lab, but we are going to talk about how to make your own coding scheme in the R script. So first, as we can see that we already talked about this, we can make a new variable out of this. And second is that choosing a specific coding scheme does not affect the overall fit of the model. You can see later that all the f-test results are identical. However, the estimates of the regression coefficients changes and their interpretation change based on the coding scheme you choose. And the third point is that generally for k groups in a qualitative predictor, we only need k-1 coded variables. Okay, so first let's get started with the dummy variables. So for dummy variables, this is the coding scheme. So we have 4 levels, Q1, Q2, Q3, and Q4. Then we need a k-1 group, k-1 dummy variables. So it's 3 dummy variables here. So we have x1, x2, and x3 indicating 3 dummy variables. And here is how you can indicate the groups by the 3 dummy variables. So for dummy variables, we assign a 1 to one group and a 0 to all other groups for each code. One group is coded 0 on all dummy variables. This group becomes the reference group against which the other groups are compared. So in this case, our reference group will be Q1. So Q1 will receive 0, 0, 0. You see, you receive zeros for the dummy variables here. So that's the dummy coding is useful when one group is a control group and the other groups are experimental groups to be compared with the control group. And you can see here, when the x1 is 1 and x2 is 0, x3 is 0, it's indicating that it is a variable Q2. Okay, it is indicating Q2. And when x2 is 1 only, and this indicating is Q3. And when x3 is 1, it is indicating is Q4. So when the 3 variables here are all 0, and we're controlling the indirection and the PDI, so the intercept will be the sales value for Q1, our control group. As you can see here, the B0 here is the predicted value of sales for Q1 only. And B1, B2, and B3, those 3 are the difference between Q1, Q3 and Q1, and Q4 and Q1 respectively. This is how you dummy code a categorical variable into the regression model. Basically, you will have k-1 dummy variables in the regression model. Okay, so let's go to the code here. In our R code, you can look at the dummy coding by typing here. So this 4 is indicating how many groups or how many levels in your qualitative predictors here. So in this case, we have 4. So if you change, like if, for example, if you have like 5 levels, you can change to 5, and if you run it, you will have another column indicating the another dummy variable. So in this case, we got changed to 4. Okay. So you can see here, this is our coding scheme, dummy coding scheme here. And then we are going to use this coding scheme into our regression model. However, in the R, when we directly put the effector, which is the categorical variable, into our regression model, it will be automatically coded as a dummy variable, as dummy variables. So we don't have to do, actually we don't have to do anything to change the we don't have to do anything to change the coding scheme. So we can just like directly put quarter into our regression model. As you can see here, we specified PDI as one of our predictors, and this is another predictors quarter, and this is the interaction term between the PDI and the quarter. Okay, let's run this. Okay, so let's get back to our result. So for this part, as you can see here, the PDI is still significantly predicting the cells. However, our intercept, as we talked about it, this is the Q1 cells. Okay, the cells in Q1 controlling PDI and the interaction term. So we're going to see the interaction term later. So this is the predicted value for Q1. And here, this Q2, Q3, and Q4, those are the difference in cells between Q2 and the Q1, Q3 and Q1, Q4 and Q1. And they are not significant. And PDI column quarter 2, PDI column quarter 3, and the PDI column quarter 4, those three variables indicating the interaction between PDI and the quarters. So you can see here, those are not significant either. And here we have a very high value of a R-square. We have 97.28% variance explained by the whole model, the predictors included in the model. And our F value is here. Okay. So as you can see here, we separated the quarter. We do not group the quarter into like two groups, but we separate the quarter into like we are analyzing the quarter in its own, like 1, 2, 3, and 4. We're not grouping some of them. We just analyze it one by one by the dummy variables. So basically, we are comparing the groups by setting a reference group, which is Q1 here, and the Q2, Q3, and Q4 are the experimental group. And in R, if you want to change the reference group into a new group, you can reorder the levels of the factor in order to change the reference group. So basically, the first level will be the reference. So here we have 1, 2, 3, 4, right? The levels are 1, 2, 3, and 4. So the first one will be Q1. So it will be the reference group. And if you run this code, the order will change to 2, 1, 3, 4. So the first group, the first reference group will be Q2. I will just skip it because I don't want to change it. You can obviously you can change it back by reordering the levels. But in this case, I'm just gonna show you how to do that. Okay, so this is dummy coding. Next, we can look at the effect coding. So the effect coding is something like here. So the equation here will be identical to the dummy coding, because we still gonna need only 3 variables here. So we're gonna need 3 effect coded variables, and since we are assuming equal sample size for the groups for the 4 quarters, we're just gonna use the unweighted effect coding variables. And here, as you can see here, instead of instead of the zeros, we have negative ones for a group here. So as you can see here, our Q4 receives negative ones for 3 of the effect coded variables. So each effect code consists of ones for the members for one group, and minus ones for members of another group, and zeros for the remaining groups. The same group received a -1 code for each of the k-1 effect codes in the set. So Q4 in this case will receive -1 for each of the code in the set. And each of the codes contrasts one group with the grand mean of all the groups. And you can see here our B0 will be the grand mean of Y. So the grand mean is actually the means, as you can see here in the comments. The grand mean is not the mean of the dependent variable, it is the mean of the means of the B dependent variable at each level of the categorical variable. So it's the mean of the means of the Q1, the means of the Q2, mean of the Q3, and mean of Q4. So it's the mean of the means. And then B1 will be the difference between the Q1 and the grand mean. So if these two plus together will be the Q1 mean. And B2 is the Q2 and the grand mean difference. And the B3 is the difference between the Q3 and the grand mean. And let's get back to our code. So as you can see here, by running this contrast sum, so you can see here the this is the unweighted effect coding in R. So it is also called the sum to 0 contrasts. So you are making a sum to 0 contrast, which is also called unaffected coding. Unweighted effect coding. Next, how to incorporate this coding into the regression model, our linear object. So here, as you can see here, we are going to specify contrasts, which in the contrast we're going to specify a list which is listing all the categorical variable with their coding scheme. So in this case, we only have one categorical variable, and then you can just list this one categorical variable here, and its coding scheme is the unweighted effect coding, right? So we're going to specify it here. So this categorical variable equals to this coding scheme. If you have another categorical variable, you can just put inside of this list. Okay. So let's run it. As you can see here, the F statistics does not change. Okay, it's still 163.8, and the R squared is still 97%. And if you go back to here, you can see here it doesn't change. Okay. However, our regression coefficients are changing. So as we talk about it. The intercept here is gonna be the grand mean. Okay, so it's the mean of the means. So our grand mean is here, and Q1 is the difference between the the Q1 and the grand mean. Q2 is the difference between Q2 and the grand mean, and Q3 is the difference between Q3 and the grand mean. And you can see here they are not significant. And here are the interactions between the PDI and the quarter. So next, we are going to see the user-defined coding, which is like make your own contrast. I think the in the past, so in the previous two coding schemes, it is not so useful for our case here. So in our case, we want to see the Q1 and Q4 group together against Q2 and Q3 group together. In this user-defined coding, you can do that. Actually, the only coding scheme we want to use is just this X1. But in some other cases, you still want to see like the pairs against another pair. So we can specify not only Q1 and Q4 versus Q2 and Q3, we can also specify Q1, Q2 versus Q3 and Q4. And then we can specify Q1 and Q3 versus Q2 and Q4. So those three can be specified here by putting the positive, putting like positive 2.5, positive 1/2 and negative 1/2. So Q1 here and Q4 here will add it up to 1, and Q2 and Q3 here will add it to -1. So 1 and -1 will sum to 0. Okay, so this is another way you can do it for the coding scheme, to compare the sum of some of the groups against another combination or another entity. For example, you can specify like Q1, Q2, and Q4, the mean of Q1, Q2, and Q4 together against the Q3 only. And that belongs to effect coding as well. But in this case, we want to see Q1 and Q4 plus together against the Q2 and Q3. So this is how you specify it. Actually, if you just put the X2 and X3 like into all zeros in these two columns, like just put zeros, the R will give you the regression model, which is like only treating the quarter into like a two-level predictor. So in that case, it will be identical to the result later we're talking about. Okay, so just remember that. Just keep that in mind. But in this case, we are going to see 3 kinds of comparison here at once. So let's just run the code here. So as you can see here, this is how you specify your own coding scheme in this way. So in this cbind column, in the cbind, we have 3 vectors. So those 3 vectors are identical to the coding variables here, as you can see here. So those 3 indicating x1, x2, and x3. And we use cbind to make it into a, as you can see here, we make it into like like a matrix. Okay, so they will become like in this way. Okay, in the column, and then we put that matrix into this contrasts. Okay, and then we show this contrast. You can see it will be like just like this. Okay, so we already put an extra stuff which is called attribute into our contrast here. Okay, into our quarter variable here. And in that case, we don't have to specify like contrast like something here because we put an attribute into our quarter. So if you run that, it will give you the result based on this coding scheme for the quarter. Actually, you can just see the coding scheme in the linear model you specified. If for example here we have a linear model 4, and in this linear model object, you can see the contrasts here. And if you type in the $, and then you will see a list, and you just call out this contrast in this LM4, and you will see that the quarter variable has this your user defined contrast coding. Okay. Okay, so let me just delete that, and let's run this result. So based on the result, you can see here the quarter 1, this one is actually quarter 1 plus quarter 4 against quarter 2 plus quarter 3. And you can see here it is significant. So we finally have a significant result here to show confirm our observation in the scatter plot and the residual plot we see before. So this is significant, right? And you can see here, since we all specified the 3 coded contrasts, like the variables here, we specify all 3. So you can see the F test is still the same value, and the R squared is still the same value. So the coding scheme, if you specify like k minus 1 variables, like either dummy variables or unweighted effect coded variable, or user defined coded variables, k minus 1 variables, you will get the identical overall F test, but the intercept and other regression coefficients are going to change. So the estimates are going to change, and their respective interpretation will change based on your coding scheme. So please keep that in mind. Okay, so next, as we talk about like long time ago, right? So in this lab, we are going to just include another variable. We're going to create a new variable, which we're going to group the Q1 and Q4 together, and the Q2 and Q3 together. So Q1 and Q4, because it's a better season to sell the ski, we're just going to create that as 1. And Q2 and Q3 are hot seasons, so we're going to just put 0, because you can just change that. It doesn't matter. It's just the direction will change. If you want to see a positive estimate, it will be better just to put the Q1, Q4, the cold season into 1 and the hot season into 0, because we're talking about ski sales. And our regression model will be this x1 is a PDI, and x2 will be the season variable, which we have only 2 levels, 0 and 1, indicating cold and hot, hot and cold, and the interaction between the PDI and the season. So let's get back to the code here. So first, because we put a attribute into the quarter variable here, which is a contrast, right? We specify a we user-defined coding scheme, so we need to get rid of that. So the first line is just to get rid of the coding scheme here. So we just remove that one. So the quarter will be the original quarter we call out from the data set. Okay. Next, we're going to use the recode. We're going to use the information of the quarter variable to make a new variable called season. So as you can see here, if the variable, if the observation in the quarter will be 1, and the new variable will be 1. And if it is 2 in the quarter, and it will be 0. If it's 3, it will be 0. And if it's 4, it will be 1. So in this case, we are going to create a new variable called season in our data set. As you can see that this season will be our new variables here. Okay, so however, this code is to reorder the levels of the season. I think if you just recode that, it will be 1 for the first level and the 0 for the second level. So we don't want that. We want 0 to be the first level. So to make our, well, it doesn't change much. It's just changing the interpretation. So it doesn't matter that much. So as we talk about that, right, the first level will be the control group. So we want to see 0, you know, the Q2 plus Q3 as our control group. So we want that one. So that's just run the regression model here as we specify. Okay. So this season variable is just to see the effect of the season. So between, you know, the difference between seasons, the cold and hot in cells, controlling the PDI and the interaction. Okay. And you can see here it is very significant. So we have a seasonal difference between the cells. And also here, we don't have an interaction between the season and the PDI. So okay, so next, since we, in this case, it is the best way to incorporate the quarter, which is a season, which is seasons. So if we go back to check the residual plot, you can see that the residuals are normal now, and you can see that the residual are scattered in the plot of the standardized predict value against the standardized residuals. So it is scattered. So we are good in this case. Okay, so that's it. Thank you for watching.